the interest of the audience's continued participation, Susanna-Assunta Sansone from Oxford will tell us about how we can really go fair.
Well, actually, it's just the title. The title was a useful one to be so general I could then decide what to cover precisely. So don't worry about it. I only have one slide about FAIR. But actually, because I want to try to introduce something slightly different, perhaps new. So I'm not going to tell you what the principles are because you know. But actually, I want to talk about the fact that the brand is becoming quite popular. And a lot of people are claiming they are fair. And, and it's difficult to understand, actually, objectively measure the fairness. So now the new activity, it's really to understand how do we measure fairness. And there are several groups which are trying to find a way, to define what the framework can be. I want to mention one group in particular, not just because I'm part of it, but also because it's closely connected to the BD2K. And in fact, the work by this group, that group, which is called fairmetrics.org, it's also being presented to the NH BD2K Fairness Working Group, which has regular calls. And so I don't have anything to present at this stage on the metrics, but as I say, this is something which is really important because perhaps the next meeting will be about applying those metrics to really understand, how fair certain data is or certain objects actually are. So we already know that FAIR is being used by many groups. It's really going global, and it's used not just in the context of BD2K, but also in Europe in the context of Elixir, which I'm also part of as Henning and many people in the room here, but also globally outside the life science community, obviously. And an example is the Research Data Alliance, where FAIR is now part of many of those working groups. But also pharma, so also the private sector is becoming interested in FAIR. And again, if you are European, you might know about the IMI, the Innovative Medicine Initiative, which is a private partnership, public partnership type of project, and they have a call on FAIR in order to make data that has been produced by pharma academics to make that data fair. So it's really going global. So I also want to use this picture to say what I'm going to cover. So I'm going to start talking about the BioCADI project very briefly, which implements the FAIR concept, which is part of the BD2K, and then jump onto another project, which is the FAIR sharing, or we used to be called biosharing, that Mark already mentioned, which is part of Elixir. It's an Elixir UK resource, but which is also fed into the CEDAR project, which is a BD2K. So as you can see, many links. I don't think I need to explain the need for metadata because Mark has done an excellent job. But this is just to say that, of course, metadata is at the core of the FAIR principles. But in order to make things discoverable and understand the terms of access, let's say, to a certain data set, you need a certain type of metadata, which is different from the type of metadata you need for interoperability and reusability. So I want to start first with the two letter of the FAIR, and of course use as example another metadata index, which is the DataMed, which somehow complements and works with the OmicsDI that Henning just presented. So BioCADI is the project which has built the DataMed prototype, which the goal is to do for data what PubMed does for the literature, so metadata index. So it's an aggregator of the repository, but also an aggregator of aggregators like OmicsDI. So I'm not going to go in the detail of the implementation. I only want to mention the fact that it's live, you can actually see and search and test it, but also works with a variety of projects which are under there that extend and enhance the functionality of DataMed, which is really about findability and discoverability. And there are projects, for example, that focus on visualizing the information, and others that focus on ranking the information. So it's a largely collaborative effort. And it's all about the metadata. So the role of my team in DataMed was actually to develop the metadata model, which is called DATS. If you probably are familiar that in order to index article in PubMed, the journal and the publisher need to provide something called JATS, the Journal Article Tag Suite. That's exactly what we use to call the metadata model for DataMed, call it that, the data tag suite. So practically, I don't want to show a slide where I show the model because nobody wants to see that type of slide. But what I want to do, I want to really mention the fact that this has been a collaborative activity, as taken a couple of years actually to implement it, iteratively testing it. And on top somehow of this diagram, I want to really show the activity that's been done within the BioCADI, working with specific use cases provided by the NIH, collected from the community, which has been converted in competency questions that have driven really the development of the model. But on the bottom, there is all the community engagement that we've done throughout by reusing, by linking with other initiatives which are developing or have developed metadata model, like under the W3C, but also the schema.org, which Henning already mentioned, which is, of course, it's essential to make data which is on the web discovered by major search engine like Google. And under the BD2K and Elixir, the work of the schema.org is being extended to Bioschema. So that also exists as a profile in schema.org and in Bioschema. And we work with Elixir, with Go, Feren, etc. So this is just a very touch and go on what is the metadata for discoverability. As I said, it's an high-level type of metadata, but if you want to make sure that the data it's really truly interoperable and truly reusable, the level of richness it's really higher. And the type of metadata standard you actually need are those developed by a lot more community, even more than those that develop the high-level type of metadata. So this is just a slide that tries to capture a really growing and huge landscape which is out there, and give only a few examples. Give examples of grassroots community which have developed this type of guideline terminology formats, and Mark already mentioned those. And so these are what I call metadata standards. Some people call reporting standard or content standard, but this is the richer metadata descriptor, a level of the experiment of the sample technology, which is essential for somebody to understand and potentially then reuse the data. On the left-hand side on the screen, you can actually see that there are also more formal organizations, standard developer organization. And the fact that there is so much out there, it's great, because each of them really, it's rooting their development in real needs, in real use cases. But you can imagine also that this creates a lot of fragmentation and also a lot of confusion when it comes to the user. What standard do I need to use? Which standard is actually mature for me to use? What standard apply to my domain, and so on and so forth. And that's exactly why, yes, as Mark mentioned, in 2008, we launched the MIBI portal, which only pulled together the checklist, but in 2011, we realized we had to map the landscape of standard, going beyond the checklist, going to the format, and then to the ontology, without duplicating the work done by the bioportal or the OLS, but just trying to map them across. And that's why we launched what used to be called bio sharing, but because people felt that bio didn't, cover agro, didn't cover chemical, but because we cover broadly life sciences and beyond, we decided to change the name, but also because, in the context of FAIR, standard are key to FAIR. So this is really a brand new relaunch, but the feeling of the system is the same. What we really do is to map those standards and create relation among them, and I'll explain you actually exactly how. So practically, this slide here really shows how we are helping the user, because over time, we have listened to them, we're working with them, and we have creating a system that has functionality that help them to find what they need. So we work with researchers, but we also work with librarians, with data curators, with developers, and with people developing data policy, funders, and journals. And they all want to know something about a standard for their domain, which one are established, which are mature, which one are deprecated, and what the versions are, and which one they should implement. And these are the type of questions we hear over and over, and that's the reason why we have created BioSharing, and we continue to work with this community. So what we actually do in order to answer their question or try to help them answer their questions, we link together the standards. So in the sense that some standards have been developed because they are, complementary to each other. Many community have developed the guideline as a sort of document that tells what you need to report. And at the same time, then they've developed the format that implements this information. Sometimes this model and the formats contain the terminology. Sometimes the the terminology is external. So there is a connection between this type of metadata that has to be represented for someone else to be able to understand what needs to be used and why and how. And then, of course, over time, as the standard mature, you have tools, you have databases that implement the standard, therefore you have data sets annotated with the standards. And that's essential because in order to show that a standard is useful to evaluate its use, you want to have data annotated with that standard. And that's why understanding which database implement which standard, it's an important metric also for evaluating the standard per se. And then obviously, as I said, policy are now starting to implement, recommend standard database. And we want to know how they're recommending, what's the criteria for selecting certain standard or certain databases over another. Another thing we have been doing with the community is to understand the status of a certain standards and a database. If it's mature, if it's in development, if it's deprecated. A lot of metadata efforts have been very good at the beginning. The group published the paper, but then they ran out of steam or funds, or the interest changed, and that metadata standards haven't been developed further. And that's what we are trying to really understand exactly what status it is. So we are now giving this indicator of maturity to the metadata standard, working with the community, which means we don't make the assumption ourselves. We contact the group, we work with the group. We only assign a status uncertain, where actually we just cannot get hold of anyone in that original group. That probably means that the group doesn't no longer exist. What we are trying then to build, it's this map of standard, not only status, but also usage. This is just a very simple example. If you start from the left-hand side, you see two databases for transcriptomic data, Geo and ArrayExpress. They're both, of course, mature and ready. But both of them implement Miami checklist, but they somehow implement the checklist using different type of format. In Geo, there are two type of formats, soft and minilateral. There are more than that. In ArrayExpress, they used to be MageML and tab, but MageML has been deprecated in favor of the tabular format, which also requires the use of an ontology. So this is important for someone to understand. If a journal comes and they want to recommend standard databases, they need to understand what they're recommending and how to select what they need to select. That's why we work a lot with the publisher and journal editor. And now I'm picking a couple of examples. I'm taking, for example, the EMBO Press journal, because I believe EMBO, I think, is the journal that the publisher that recommends many more standards over the other. So what we are now, it's analyzing the number of the recommendation. And we see that journals tend to implement databases 28 times more than recommend standards, but not because they don't want to, but perhaps because they need to be made aware that there is a standard implemented by databases, and if you recommend a database, you are implicitly recommending the standards. So, and what we do, we work with them, and we represent their data policy, therefore their recommendation of metadata standards and databases in the fair sharing system, and we have this graphical representation which make them actually see what they do. What we also do have, it's a feature that shows the publisher or anyone that has a data policy with recommendation what they do not recommend, but they should, because it's either connected to something they recommend. For this is an example. If you look in the zoom-in picture, you can see that Chemosys, which is a database for system biology, is being recommended, but the two standards, the SLML and SBML, which actually are marked as ready, therefore mature, are not. Although they should, because if you recommend the database, you are implicitly recommending the standards. I'm going to go to the last part, probably in a couple of minutes mark I will do, which saving a few minutes over the schedule. I want to now move to something which is a research activity, which we are doing as part of the CEDAR project. So practically, there are a lot of these metadata standard, and the way they've been developed starting from either a biological domain of interest to that community. I work on plant, I want to represent plant, I make sure I have standards to describe any plant experiment. This is how I start the development of a standard, fair enough. There are community working on metabolomics, and doesn't matter the sample in their experiment, they work on developing a standard from the metabolomics using the different, think about the different technology for metabolomics application and develop standard way. But this is great because you need to anchor to what really you need to do. But the truth is, the problem is that there are overlaps. There are areas in which actually the standard should work as a piece of a puzzle, and you can plug them together, especially because there are common features, there are common metadata elements which should actually truly be common. But the fact that these efforts are, working sometimes in isolation, sometimes in connecting, there are this duplication. And these duplications are a little bit problematic when you try to represent an experiment which encompasses many technology, or you try to integrate data from different sample types. They perhaps have been standardized, but the standards tend to be different. And by the way, it's better to have a metadata standard than nothing. But nevertheless, the ideal scenario would be that this metadata element, they will be, a piece of a puzzle that you will be able to combine the way you need to represent the experiment you need. And this is a little bit of a busy slide, but really represents exactly what we're trying to do in the CEDAR project. So in the fair sharing, we have the record of the standard, and we know which database implements which standards. So in order for someone to go to the CEDAR system and say, create me a template with the metadata element that match the Miami, but I'm submitted to GEO, therefore you need to know that there are different type of format used by GEO and perhaps even different metadata label for the same Miami element. This is all the provenance information it's stored in biosharing, and by creating this metadata element as machine readable and composable, you are able then to use the CEDAR system to pull together the components which are relevant to you. And with this, I just want to thank, of course, the BioCADI and the CEDAR collaborator, but especially my team, which is working on this project and on the fair sharing system. Thank you.
Hi, I thought I'd ask a question about DataMed. I was looking at it, and I see that so far you have 66 data sets, 66 resources indexed there. I'm assuming you're going to add a lot more. I notice you have UniProt now. UniProt is a great data set, but it has something like 400,000 proteins in it. Mm-hmm. If you add all of GenBank, all of PubChem, there's going to be a huge amount of results when people do a search. I'm just worried that searches will just yield so many results that they'll be useless. Do you have ideas on how to address that problem?
That's a good point. I'm also looking at Ian, which is Ian Forrest down there, to help him with this. So one of the projects actually, which is on the Biomed, which I didn't have the time to describe, and I think that will be the most useful one to try to sort through it's the data rank. I think it will be, this is the thing, this is our pilot project which are being added as of now, which will be able then to refine the searches wherever actually you need it and rank it what's most relevant to the type of query being run.
Right.
I'm afraid I won't be able to reply any more technical because my activity has been on the metadata model rather than on the implementation of it.
Yeah, one thing you might try is to let people search subsets of the data.
Right.
To say, well, now I'm interested in chemical data, or now I'm interested in omics data. That might help.
Yeah, no, fair enough. That's appreciated, and I think that's exactly that's possible. Yeah.
Okay, thanks.